Muted.
According to alighting flows and expanding, again, socioeconomic and travel characteristics, and then we'll conclude the presentation with the summary of the findings. To first motivate the notion of expansion, why are we interested in socioeconomic and travel characteristics, and why are we interested in expansion? Of course, we all know the socioeconomic and travel characteristics of passengers are important for service planning, for responsive service provision, but also they're required for reporting purposes. These characteristics are traditionally obtained through extensive surveys, typically carried out through, again, either written form or interview form, onboard transit vehicles. The samples tend not to be very large relative to the ridership. In addition, there could be sampling biases, but also the nature in which responders elect or decide to participate or not may lead to also different types of biases that may over or under estimate some of the characteristics we're interested in. The characteristics are associated with the spatial patterns, the movements on the route. They get what we call, again, the boarding to alighting flows, and therefore can be adjusted by those characteristics, by those flows, if we have an accurate representation or a realistic representation of these flows. So we can adjust, and that adjustment is called expansion, to correct for some of the biases, whether sampling or again, behavioral related, that may result. And that's really the main question that we're interested in this study. Now, those boarding to alighting surveys that are typically conducted completely separately from the onboard survey are intended, again, to produce reliable or representative flow patterns on the various routes to be used for the adjustment purpose. So from here on, we're going to use the word expansion instead of adjustment. I guess that's the common terminology used, and it would be very useful to go over the basic idea of characteristic expansion using boarding to alighting flows. Starting with the main inputs, first of all, on the right portion of this diagram, you see the onboard survey characteristic. And as an example here, we're using gender to illustrate the idea. As a result of the onboard, let's say, interview-based survey, we are collecting information about by origin or by boarding to alighting cell, for example, travelers boarding at segment 1 on the route and lighting at segment 1. For example, we observed 11 females in total through this onboard survey. For that same cell, from segment 1 to segment 1 on this route direction, we observed 15 males, for example. And similarly for all other feasible cells in this boarding to alighting flow characterization. So based on this, only the onboard survey, we could simply look at the total females riding the route, total males riding the route, and calculate the proportion of females riding the route, and of course the proportion of males as well as the complement. So, and that's what we would produce if we were to only use the onboard survey data for this characteristic determination, in this case, gender. Now we're saying, well, the actual numbers that we observe in the various cells in this onboard survey, partly because of the sample size not being as high as the ridership, and secondly, because of the biases that may result in the way people respond to these surveys, the question becomes, can we correct for these biases using some information separately determined regarding the actual patterns of movements from boarding segments to alighting segments along the route? And that's what we're calling the boarding to alighting flow information. Again, this information would be, again, gathered completely separately from the onboard survey exercise, resulting in actual observations of volumes. Notice here in this, again, illustrative made-up example, we're specifically using larger numbers to indicate the larger sample involved here, but also those are done in a manner that do not reflect any, are intended not to reflect any biases in the way travelers respond, because we're not asking them any questions, but rather, we'll talk about that later, carried out in a manner that is not expected to result in biases. So with this now piece of information, how could we go about the so-called correction or adjustment in the gender characteristic? So two steps first have to be carried out. First, we convert the boarding to alighting flows into what we call proportions, or sometimes we call them probabilities. This is not basically normalizing the cell-by-cell volumes by the total, resulting in the proportions of travelers that are, again, traveling across the variety of feasible cells or segment-to-segment movements on this particular route. And that's what we are calling here. These are the proportion of boarding to alighting flows. In addition, we can convert cell by cell the proportion of females and males observed in the onboard survey regarding gender. So in this case, for example, we're saying there are 42% females among those traveling from segment 1 to segment 1 and so on and so forth for the entire, again, matrix or table of boarding to alighting movements. So the premise here is that these numbers are accurate or are representative, are not subject to cell by cell, subject to the biases. The volumes are, but not the actual proportions. And therefore, we can now apply the weighting of these proportions by the distribution of the travelers in the boarding to alighting flow to produce the, again, weighted numbers you see in this table I'm pointing out in the cursor. And then, of course, taking then the sum of those. Basically, this is an expectation calculation. Taking the sum of those would produce what we call the expanded proportion indicated in this red ellipse over here. So basically, these numbers are, we're taking the expected values. This is the probability density function. These are the observations. And then this is basically an intermediate step to calculate the expected value. And of course, we notice here that this number is different than what would be produced simply from the onboard survey alone. Right? And that's the basic idea, and that's the result of an expansion in this case, where once we take into account the actual movements, the flow patterns, we have a different number. In this case, happens to be lower than for females, lower than what would be produced from the onboard survey. So that's the basic idea. And it's important to kind of lay it out because that's the main mechanism used to conduct the various analyses, or one important aspect of the various analyses of this study. All right, so now kind of moving onward and speeding up a bit, let's talk about the project objectives. The primary question is, can we reduce or avoid? Notice again here, these are the B2A flows. These are the actual results from the onboard survey, specifically as an example for gender. These are the inputs. This would be the so-called expanded output for this particular example. Can we reduce or avoid the cost of manual B2A surveys for expansion? These are not easy to come by. They're expensive. Can we reduce that cost by basically maybe using lower sample sizes? Or can we eliminate the cost of actually getting on the buses and collecting these boarding to alighting flows by using other sources of data? Particularly here, we're interested in the use of automatic passenger count data and automatic fare collection data or fare box data. We're interested in expanding the socioeconomic and travel characteristics with various inputs, various estimates of these B2A matrices. So when we change this, we're going to be coming up with different expansions. And finally, we're interested in comparing these characteristics expanded based on different boarding to alighting flow values or proportions eventually to what we would consider to be a ground truth. What would be a ground truth actual characterization of these flow patterns? And as a result, we would be capturing the impact of the use of the certain B2A flows in the results or the quality of the expanded results or characteristics. As another kind of parallel objective that comes out of this is, of course, now that we have multiple ways of determining B2A flows, we're interested in the question, are the B2A flow matrices estimated without the B2A survey data of similar quality to those estimated with present levels of B2A survey data, the survey samples? So right now, these B2A surveys are conducted, again, on board. And the question is, are these other ways of coming to the B2A flows. How do they compare to the ones that are derived from the surveys, the expensive surveys? So we're interested in estimating the B2A flow matrices with different sample sizes, lower and higher, and using also APC and AFC data. And then we want to compare the various results against, again, a so-called ground truth. Before going into the details, the overall findings of the study are the following. First, the B2A survey data collected at typical sample sizes offer little, if any, improvement in producing more accurate B2A flow matrices compared to estimates that rely only on readily available APC and AFC data. So this is basically just as a result of comparing the B2A flows using different sources of data. Secondly, the errors, so assuming we know the ground truth, the errors in the estimated B2A flow matrices used to expand the socioeconomic and travel characteristics are actually attenuated when we are considering the expanded socioeconomic and travel characteristics. So once we use the B2A flows, if we have a certain level of error in the input, that error in the output captured in the difference between the actual expanded socioeconomic and travel characteristics against the ground truth socioeconomic and travel characteristics, we see a reduction in that error. That's the attenuation we're talking about here. And finally, the B2A survey data collected at typical sample sizes, again, this is crucial, typical sample sizes in practice, offer no systematic improvement for expanding socioeconomic and travel characteristics compared to B2A flow matrices estimated from readily available, automatically collected data, again, in this exercise, specifically focusing on automatic passenger count data and automatic fare collection data. Again, before going into some of the specifics of the analysis and how we arrived at these conclusions or these findings, it's important to highlight several implementation issues. We've encountered several issues that in most cases were not anticipated ahead of time, and that required quite a bit of additional analyses and efforts. Most crucially, we spent quite a bit of effort assessing the quality of the various estimates to be used based on the comparisons. So basically, the results relating to what we would originally intended to use as ground truth data in the boarding to alighting survey basically was found to be of quite poor quality. So the B2A survey data that was intended to represent the ground truth at fairly high sample sizes was too poor to serve as the ground truth. So that really added an important complexity to the project and how we would go about the analysis and interpreting the results. One solution, this solution we came up with is to basically say we don't have any more a ground truth to compare to, so we came up with several references, what we call now reference B2A flows, to conduct the comparison. So now the comparisons are being conducted against multiple references. And then another issue we dealt with in response to the quality of the data is to go about a way developing a methodology to screen for the quality of the B2A survey data and basically be able to say which ones do we trust and which ones we don't trust for specific bus trips on a specific route. And that again requires development of procedures and large-scale processing and analyses that allowed us to screen out those poor quality B2A trips and use the remainder to conduct, again, more reliable comparisons. Again, we'll talk about that in more detail later on. Other data quality issues related to APC and AFC, we'll mention some of those again subsequently. But basically, we have to develop and apply procedures to screen and correct for the various data issues associated with actually APC and AFC data as well. Other implementation issues had to do with the fact that in some instances, the onboard survey B2A flow matrices would have zeros in them for certain segment-to-segment cells. Similarly, the boarding to alighting survey would have zeros for certain stop-to-stop. In that case, in fact, the analysis was conducted at the stop level and then aggregated to segment level across the route, where a segment is a grouping of stops. Again, these zeros could result in inconsistencies and analytical problems, so we had to come up with, again, extensive, rigorous procedures to deal with correcting for these zeros. Specifically, when we have zeros in the B2A survey, it's not trivial in terms of coming up with solutions, and then had to, again, develop various methodologies and test them and apply them to arrive at these corrections. The zeros in the onboard survey data, again, not a trivial matter, but not as complicated. We use the marginal data in this case, to marginal meaning total boarding and total alighting, to fill in the gaps where there are feasible cells, feasible movements that are not observed in the onboard survey due to the small sample size. And again, we use an approach used by AECOM in a separate study for COTA in this case. Naturally, we have a lot of data, a lot of a wide range of routes, a wide range of directions, of course, the time of day, and also many characteristics that are observed in the onboard survey. The results of which imply that we have to develop very extensive, efficient computer codes to be able to conduct these runs on multiple locations. In addition, of course, we're wanted to test the effect of sampling. So if we have a large or small sample of B2A survey data, onboard B2A survey data, what's the effect of sampling? And again, we wanted to run the analyses for different sample sizes, and of course that again required a large number of runs. Very quickly to go over the data used in this study, there were 4 sources of data. I'm going to march through them one by one and point out several issues and aspects that we had to deal with. First off, the onboard socioeconomic and travel characteristics survey basically looked at collected data on passenger demographics, socioeconomic, travel, and location-related information. These data were collected by ETC Institute via a personal interview survey in the spring and fall of 2013. ETC applied quality control tests and measures. Just in aggregate, the onboard survey captured almost 8,000 passengers and 12,500 passenger trips, basically recognizing that most of these passengers were making round trips. The second category of data considered here are, of course, the boarding to alighting passenger flow data conducted through the B2A survey. This is done at the stop-to-stop, again, level, so we are capturing the stop-to-stop passenger movement on the various routes. Again, these data were collected by ETC using, again, a totally separate procedure than the one for the onboard survey, based on geocoded cards that are handed out and collected for the boarding and alighting passengers. ETC Institute, again, applied quality control tests and measures. On top of that, we at OSU identified several additional data quality issues, mostly related to the direction of travel that we actually were able to, in most cases, apply corrections for. We also, on our end at the OSU team, we mapped the surveyed passengers to bus trips by route direction based on the block ID information and the boarding times of the passengers. So now we could actually associate a actual passenger traveling on specific bus trips along the various routes. Again, overall, in the B2A survey data captured the boarding to alighting stop pairs of about 45,000 passengers traveling on approximately 2,500, 2,400 bus trips. In addition, continuing with the issues associated with the boarding to alighting survey data, observations, again, on quantitative comparisons to APC data led us to conclude that the quality is quite poor. We developed and applied various criteria to screen for the erroneous data. We corrected the B2A data for, again, what we call partial observations of certain bus trips. So in many cases, the actual data collectors would not be boarding at the various terminals, but would be boarding halfway along a bus trip. That resulted in incomplete boarding to alighting flows. So we actually had to develop procedures to fill in the unknown or unobserved portions of these tables, these boarding to alighting tables. We aggregated the stop-to-stop B2A flows into what COTA and AECOM previously defined to be segments along the route. And we also aggregated the B2A passenger flows into what COTA considers to be the 4 time of day periods based on the passengers' boarding time. The third source of data is what's derived or what comes about from the automatic passenger count technology or system. COTA has about 20% of its fleet equipped with APC technology, and the data was again communicated to OSU. Data encompassed here in the order of 98,000 bus trips, and more than 2 million passengers again were observed and considered in this study. OSU applied again previously developed procedures that we developed on previous studies to eliminate again errors in the APC data where we have large discrepancies basically between the total boardings and total alightings on a particular bus trip. And this resulted in about 35 to 41% of the bus trips being removed. So large discrepancies were indicators of poor quality data, and those again were removed for further consideration. The fourth and last source of data are the automatic fare collection data. COTA collects swipe-on electronic fare media transactions. In this case, the data we looked at considered more than 8 million passenger transactions. The problem was that this was a recently implemented system, and the location information associated with the AFC transactions were still erroneous. We luckily were able to correct for these errors because the AVL system associated with the AFC was completely separate from the AVL system associated with the APC technology. And because the timestamps in both data sets were actually accurate, matching the timestamps between the AFC data sets and the APC data sets allowed us to migrate the location information in the APC data set to the AFC data set, and resulting in a correction of location. That's the advantage. The disadvantage is only 18 to 20% of the AFC transactions were able to be corrected because COTA has only 20% of the fleet equipped with APC. Now, of course, in addition, because this is only swipe on, we had to infer where the passengers are alighting to complete the B2A movement from AFC data, and that information was inferred from transactions relating to transfers and return trips. Of course, those require that APC is available for correcting the location information on these other trips, and very quickly the number of AFC transactions that can be used eventually ended up being less than 4% of the total AFC transactions. All right, well, at this point we're going to transition. Mark McCord will present the actual B2A flows we've used in the study, and then go through the comparisons of these matrices or tables.
Okay, thanks, Rabia. Hello, everyone. I'm Mark, taking over now. And with this background on the motivation, objectives, and the data used, I'm going to give an overview of the empirical part of the study where we compare different empirical results. The essence of the empirical study is to estimate something by different data sets, either a B to A flow matrix at the stop level, a B to A flow matrix at the period level, or a set of expanded socioeconomic characteristics, compare those to some reference value, do it for different trips, periods, routes, directions, samples, etc. Look at the distribution of the results and draw some conclusions. The essence in this, the element that we're trying to estimate or come up with a good approximation of is this B-Day flow matrix. It's boarding to lighting. How many people are actually boarding in one segment and lighting at another? As mentioned in the motivation, we're interested in how well this can do, how well different approximations, for example, using data that's already available from APC and AFC, data that's already being collected without the manual surveys, how well they can do is both in expanding the socioeconomic surveys, the characteristics, or just for themselves for a variety of purposes. So let me briefly just tell you the types of matrices we estimated or determined this for our empirical comparison. First one at the top we'll be calling B to AS. This is the B to A, the boarding to lighting flow matrix that we get from using all of the data in the manually collected B to A survey. We get this for a specific trip. You know, if they collected data on a specific trip, we'll say what were the B-day movements for that trip, or we'll aggregate them later on and get them the B-day movements from one segment to another for a time of day period. This B-day survey, the idea, these were manually collected in our study for most routes at very high levels of sample size. Because of this, you know, they're even greater than what's called the 100% sample size, where 100% sample size is usually meant to be getting a survey equal to what would be the average volume, the average ridership for that time of day period. So from those large samples of B-day survey, we got what we called X% B-day surveys. And this would be a sample of the overall B-day to represent what we could do at different sample sizes. Our understanding is traditional sample sizes are between 10 and 25%, usually around 20% of the daily ridership. And so we said, what would we get if we got 10% sample of the daily ridership? What would we get if we got even greater percents? What if we got 100%? So we're going to look at those different matrices with these different sample sizes. We talk about it briefly or a little bit more than briefly in the report. I'll skip it here, but the way we sample, we try to replicate what would be done in practice. We don't sample passengers, we actually sample bus trips until we get this actual ridership. So we randomly sample, let's say, 10% of the bus trips during a time of day period, keep sampling trip by trip randomly until we get 10% of the average ridership. Then we go and get another 10% sample. And for this study, we take 10 samples each of the 10%, 25%, etc. The third matrix we get are for a bus trip, what are the B-day flows we get from the AFC data, or if we aggregate all the AFC data in a route direction and period, what is the B-day matrix we get from the period? This is obtained directly from the fare card data, as Rabia mentioned, where we get the swipe on location, what segment they swipe on, and we infer the swipe off location from the rules we developed, the traditionally used rules, basically for return trips or transfers. Let me go to this last one first. We call it the IPF, I'm calling it seed here, and this is where we use APC data with the traditional, what's called iterative proportional fitting method, which basically adjusts, you take a seed matrix, think of it as a first guess of what you believe the boarding or lighting flows are. You use the number of people who boarded each stop, the number of people who alighted each stop. Use this method basically to adjust the matrix so you get equality between what's given by the matrix and what's given by, in this case, the APC counts, how many people boarded and alighted each stop. This is what we call the state of the practice procedure, because if someone were to use this, and people do use this in practice, some method to adjust the boarding and alighting counts to get a matrix, it's usually with this iterative proportion fitting method. We do research and work in other methods, but this is the one we chose for this study because it's sort of the most commonly used one. The result depends on what seed you use here. So we're talking about if we were to get a first cut matrix based on all of the survey data, we would call that the IPF with a B to AS as a seed. We would also look at what we get if the IPF, if we get a survey sample with, let's say, a 10% sample of the B to AS, or 25%, we'll get different results. We'll also use the AFC data, the matrix we get by using the AFC data as a seed matrix for this IPF. I lost my cursor here, but and finally, we'll use this null matrix as a seed. I'll talk about that in a minute. Just to be a little bit clear on this, we're going to be looking at both B-day matrices at the bus trip level and at the route direction period level. But for the seed to make sense, we can talk about this later if necessary. That seed is going to be constant for a route direction period or for a bus trip. We want to use the same seed. So these seed matrices are all estimated for a time of day period. So for example, we'll look at a bus trip that's occurring in the morning rush peak period, and we'll get a B to AS seed based on all the data in that morning peak. Use that as the seed, use the APC data for a specific bus trip and estimate what happens on the bus trip. We'll see the results in a second. Finally, we use this null matrix, which is basically assigning equal passenger flows to all the elements in the matrix. And I'll be a little more detailed on that in 5 seconds. The idea of the null matrix is it's called an uninformative matrix. It's what you would do if you had absolutely no information historically or any information to get an estimate. So we use this as a reference in terms of how well all of these other matrices can reduce the error from the null matrix. And just sort of a slight technical detail. The null matrix we form at the bus stop to bus stop level. We assign equal passenger flows for every boarding to alighting flow from the stop to stop matrices. But then when you aggregate them into trip segments, you can get different flows at the null matrix for different segments of segments. Just sort of a technical difference there, but it's pretty small based on our analysis. We can talk about it later if it's of interest. So let me now move to the specific comparisons that we've introduced of those matrices. And we're going to look at, as we said, the main comparisons we're interested in here is how well do the B to A flow matrices do in and of themselves for a variety of purposes. And then how well do they do for a specific purpose, being expanding the socioeconomic characteristics. And to look at how well the B to A matrices do in and of themselves, we're going to do 2 types of comparisons, one at the bus trip level and one at the route direction period. To start with the bus trip comparisons, basic idea is we're going to get a B to A flow matrix for a specific bus trip from terminal to terminal, and compare the different estimates we get and say how well do they compare to the reference. We do it at the bus trip. I mean, if we're trying to say, I'm trying to figure out what the flows are done on bus trips. And so by that measure, by that reasoning, the bus trip is the most fundamental level of analysis to compare these B to A flows. And so that's why we do it here. We'll see later when we get to the period level, we need large samples, they're more stable, they're more useful for practical analysis, for practical applications. But if we're trying to look at the quality of the B to A matrix, it makes most sense to look at that at the bus trip level. So to compare the B to A matrices from some data set, let's say from the AFC data set, how well does that do? We want to say, let's get what would we get for the B to A flows using AFC data on this bus trip, and let's compare it to the ground truth B to A flow. Well, as Rabia mentioned before, we were originally hoping that we could use the B to A survey, the manually collected survey of passengers boarding and alighting of the geocoded data to get us the ground truth of the B to A flows. But because of the difficulties we had with the quality of the data, there was no ground truth for this study. So we replaced the ground truth with what we called reference matrices. And we thought the most representative ones would be the B to A survey, even though it's a questionable quality. And then we would also think that we could correct the quality somewhat with the IPF method by using the B to A survey as the seed and then using the IPF method with the boarding and alighting counts on each trip estimated matrix. This, of course, would have errors because of the estimation errors in the IPF method. We can't tell you which one of these is better, but we see we get pretty stable results depending on, we'll see we get pretty stable results whether we use the B to AS or the IPF B to AS as the reference. So the idea is we'll get something, for example, we'll estimate a B to A flow matrix on a bus trip using the AFC data. We'll compare it to this reference, the B to AS, and we'll compare that same AFC-based estimate to the IPF B to AS. Just see how different they are. Well, to figure out how different they are, we need some measure of difference, and we use a commonly used measure called the Hellinger distance. The Hellinger distance is commonly used to compare sort of probability or proportion matrices or vectors. Again, in a long interview or presentation like this, not expecting you to absorb the details, But basically, we look cell by cell. We say basically from boarding segment 1 to alighting segment 1, what do I get with my estimated matrix? Then I take the difference of that with what I get with my, in this case, reference matrix. Take the differences, square them, sum that up over all cells in the matrix, and then take the square root of that. And basically, it's a measure that basically has some theoretical justification. And for this presentation, let's just understand that it's a distance measure or difference measure. So a lower value means the estimates and the true values are closer together. And we'll be using that for our comparison. So the other thing we're going to do at our bus trip level, the other thing we'd like to do at our bus trip level is we want to compare the different estimates we get for our B-day flows on the bus trip, basically with our different data sets. And to do this, therefore, we needed to match. We needed to get bus trips where we simultaneously had B-to-A survey data, the ones collected by our data collectors in the field, where we also had APC on the buses. As Rabia said, only 20% of the COTA buses, roughly 20% of the COTA buses had APC. We tried to schedule as best we could those to match where we were doing the survey.
Can I ask you a quick question?
Yeah.
On your distance measure, what is the theoretical reason for square root, then square root again?
Got it.
Again, there are multiple measures. This one has, from a statistical point of view, properties that were found to be more stable. But what we've done, in fact, in other studies, not in this study, we've used other measures. And basically, irrespective whether it's chi-square or the Hellinger distance or, again, a variety of other mean square error, we found very little difference in the results. But there is, specifically for probability density functions, you find better statistical properties for this type of measure. Again, that's turned out not to be very consequential when you compare it to other measures. So more or less all produce similar results.
And I'll tell you, I don't know the theory. I just used to work with a statistician, said this is what we use. We can take your
we work with like root mean square a lot.
Yeah,
we
right.
Square,
right.
And then sum, and then square rooting first. I'm just wondering why that is significant.
Right. Yeah.
No, you great. I'll send you the reference, and you can figure it out. We just basically said, I take it. Rabia knows a little more than I, but you can talk about it afterwards. But I'll take the statistician saying, this is why we do it. They say to do it. Thanks. Can I go on? Yeah. Okay. So, so the idea is we wanted to get data. We wanted to look at a bus trip and look at how we get these different matrices on the bus trips. So we want to simultaneously get B-Day survey data, APC data, and ASC data on the same bus trip. And that's what we said. We had to find, of all the bus trips we had data for, which ones had all three of these data sets, which basically passed the screening test, which I'm going to talk about in a second. The other thing, because we're doing this at the bus trip level, we want to, and it's the most fundamental level for analysis, we hoped to at least improve somewhat the data quality. So we could say we're comparing with this APC data and the B-to-AS data that at least we believe is of pretty good quality. And that's where we spent some time trying to screen these data for poor data quality. And we go over this in pretty much detail in the report, but let me just sort of give you an overview here and point out a little bit more detail on one of them because it brings up some issues. So screening of the data, again, the purpose is to get better quality data so we can have more belief in our comparisons. You know, basically garbage in versus garbage out. If we can have better quality on the inputs, we'll believe we have at least more representative, more valid comparisons on the output level. To screen the data, the APC data, we use what we've used several times using with APC data in other studies. We basically said the total number of people boarding on a trip and alighting on the trip should be roughly the same. And therefore, if the APC data show the total number of people boarding and alighting are very different, we're going to throw that trip out. We have criteria for that. We'll talk about those later.
Ravita said we had thrown about 30 to 40% of the trips with APC because of that.
The AFC data to screen, basically, we didn't really do any subsequent screening. We just said if we could infer the passenger alighting stop from the swipe on, we were going to use it. And again, we could infer it if both the trip where the passenger was boarding and the return trip or the transfer trip had APC data, that was necessary. And then we had to be able to match the times in the APC and the AFC data set. Talked about that, getting about 4% of the trips we were able to do that. And then remember we said that the B-Day survey data was of questionable quality. So we spent some time trying to see if we could develop ways to say which trips had better B-Day survey data than others. And I'd like to spend a few minutes here to go over this. So this is the screening of the B-Day survey data. The basic idea here, we use several measures here, several criteria. One is to look at the trip level total volumes, and the second is to look at the boarding and alighting activity. On this slide, we're kind of representing what we did with the trip level boardings. On the x-axis here, we have this ratio value. It's a little bit hard to see on this screen here, but this is the ratio. The number of people on that trip is determined by the B to A survey data divided by the number of people obtained in the APC data. The motivation for this is looking at the data and discussing with the data collection company that even though they do a good job of trying to get a lot of people surveyed, you don't get everyone on the bus trip surveyed, even with the B to A survey. And sometimes they didn't get many people at all. And so we believed, at least it kind of makes sense, that the more people you get in your B to A survey on the bus trip, the better the quality of that. So we wanted to say if the B to A survey is close to what we get, the volume in the B to A survey is close to what you get in the APC volume, we'll say that the B to A survey was probably a pretty high sample size survey. And so we expected values close to 1 to be better than values, for example, close to 0.2. This is a measure of discrepancy. I'll mention that in a minute, but you'll see that sure enough, this kind of works out that as the ratio goes from 0 to 1, as we get closer and closer to getting a higher, to all of our passengers on the bus trip sampled with the B to A survey, we're getting better quality data. Now, we don't have the ground truth of what the real volume was, so we couldn't say how well what was the true proportion. So we came up with this measure that said, let's look at the mean ratio of how many people are sampled in the B to A survey divided by the APC sample, by APC data, versus how will the resulting B to A matrices on the bus trip perform with the B to A survey data and with what we call the IPF null. The IPF null is, let's just use the APC data, which is incorporated here in the ratio, in the denominator of that ratio. Let's use that data and try to estimate a B to A matrix without any further assumptions. And we took the difference between those two matrices. Now for this comparison to sort of hold water, we need both this ratio to work, basically that it makes sense that as I get a higher proportion of my APC volume sampled through my B to A survey volume, that will lead to better quality, and the better quality would be represented by lower differences between these two matrices. If you're following the details, and it's a little bit tough here, that requires that both the B to A survey matrix, which we're trying to say, or which we're trying to investigate, is of better quality, but also the IPF null matrix has some valid representation of the B to A flow. So we were kind of very encouraged here that as this ratio increases, as we get a better and better sample, we're getting better and better correlation or association between what we get from the B to A survey and what we get from the IPF null. Which basically, now that could happen because just by chance over these thousands of trips, they're randomly producing more similar results. We don't think that's the case. We think they're producing something valid, and that ratio goes up. Now,
once the x-axis ratio gets greater than 1,
that can good segue. That's what I we noticed this was very good going to 0 to 1. And we were flummoxed, perplexed, whatever, and this sort of set us off for a month or two right here. That when we looked at ratios greater than 1, things went up and the difference got worse. But if you look at ratios up here about 1.4, those were where the data were actually being just as good, even better than at 1. This is meaning when the B-Day survey data were 40% higher than what we got from the APC, we were actually getting the best match between these two. We triple-checked these analyses. We kept getting it. We tried to explain it and see what we could explain. We never got it. And I'm hoping, Greg, you're going to say, you know what's going on. we basically said, we just got to cut it off and move on because we couldn't explain it. We were trying to figure out, were certain routes contributing to this, were certain volumes contributing to this, because remember, this is the ratio. We couldn't find any systematic reason. So we basically used our a priori reasoning that said, maybe a little bit greater than 1 we could accommodate. We can't explain this, so we're going to say we're only going to use bus trips that have a ratio less than, turned out, because it increased after 1, we're going to say a maximum of 1. And then we said, what would the lower bound on this be? And we did some detailed analyses, but basically it turns out kind of what you see in the picture here. There's not much difference between about a 0.8 and a 1. If we go too high, we're not going to get enough bus trips left over for analyses. If we go too low, we're going to get poor quality data. So we basically said we're going to retain the trips where the B-to-A survey has a ratio of the volume compared to the APC between 0.8. We also did, another measure here, which is basically looking at the boarding and alighting activity in the two data sets. Basically saying if we saw someone board in a segment which would be to a sample, we want there to be a high probability that we saw with the APC data. And again, in the interest of time, I'll skip the details, but we basically settled on a third parameter which screened these data. And the short of it, again, I'd be happy to either, follow up now or maybe better at the end, is that when we did this to get the high fidelity at the trip level, there were only 34 bus trips out of the thousands of bus trips we had that we could match AFC data, APC data, and B-to-A survey data and still pass these screening thresholds. So we do the trip level analysis with these 34 data. We'll see when we get to the root period analysis that 34 was too little. We're going to use all of the bus trips for that. So basically the idea was at the bus trip level, we're going to look at 10 samples of 100% B-to-A survey, use each sample as a seed, come up with an IPF estimate of the B-to-A on that bus trip, repeat it for the 10 samples, do it for all the 34 trips, look at each one of those compared to what I would get with an IPF B-to-A survey as the reference for that trip, get the Hellinger distance, look at the mean, look at the standard deviation, percentiles, etc. We came up with distributions. Do that again for a 75% sample of the B-to-A survey, down to a 10% sample. Do it for our unique IPF AFC matrix. Again, we'll have 34 of these because of the 34 bus trips. Do it for the IPF null, etc. Through all of these. Then we'll rather than try to absorb the table, and we do it once with using the B-to-A survey as a reference. We use it the second time using IPF B-to-A survey as a reference just because we don't have ground truth. Rather than try to absorb the tables, and the tables will show us this variability, let's look at some plots of the means of these things. At the very top is this uninformative matrix. Again, this is mean Hellinger distance compared to a reference here. At the very top is what we would get if we had no information at all. So that's sort of our reference, the note. If we only use the AFC data from the inference, we can reduce the error, if you want to call it error, again, it's not necessarily the truth, it's the reference, but we'll be calling it error here. We'll reduce the error by this much. However, if you use any of these methods, notice they all incorporate IPF, we reduce the error substantially down to here. So the moral of the story here, and even with the other reference, we get the same thing. We reduce, if we use IPF data, or APC data in our IPF method, we reduce the error substantially. So the first sort of moral here is using APC data is valuable, at least in this study. Secondly, this is plotted here as a function of the B-Day survey sample size used as the seed for the matrix. So if I have no B-Day survey as the seed, that's our famous IPF null. That's just using the IPF with this uninformative matrix as the base. If I use a really high level survey as the base, we decrease the error by this much here. Notice that's a pretty low amount compared to what we get if we start from the null all the way down to here. More importantly, when we say that typical sample sizes are usually around 20% of the daily ridership, we're seeing very marginal improvement by the increased sample. This flat line here is the AFC, IPF using the AFC as the base. So the moral of the story here is use IPF data, use APC data, even with the IPF method. The increased sample size isn't contributing much. And if you look at AFC for IPF AFC here versus IPF null, there's not much difference. Over here, we see AFC versus IPF null, a little bit more difference, but the same result. So no matter which reference we come up with those two sort of conclusions. Because of the variability we saw in these tables up here, we said let's not just look at the mean, but let's look at the number of times, the proportion of times that, for example, the IPF null matrix would outperform the IPF using a 10% B-Day survey. Or the proportion, so basically, if I use this B-Day survey as a reference, the IPF null outperforms at 48% of the time. If I look at the percentage of the time the IPF null outperforms a IPF method where I use a 25% B-Day survey, it outperforms at 46% of the time. Here's what we get if I look at how much the IPF AFC outperforms these guys. Here's what I get if I look at how the AFC outperforms the 10% survey and 25% survey as the base. We basically get the same results as before, that using these data as a base, 10%, 25%, kind of bracketing what we would get in practice, really doesn't lead to too much of an improvement. We're getting basically 40, maybe here 30%. This is the IPF using it as a null, using no manual survey. We still are outperforming a high sample size of 25%, 30% of the time. And if you look at the difference here in terms of the decrease in the average, we're not seeing much decrease. So kind of, we can go back to this in more detail in the summary, or in the discussion, but using, the basic conclusion is using APC data seems to be valuable. If you have it and APC is out there, use it. Increasing the B-Day survey sample size only gives you marginal improvements. And for practical sample sizes around 20%, we really see almost no improvement compared to using data that doesn't require a sample, IPF null, IPF AFC. And then finally, IPF AFC is slightly better than IPF null. Trying to speed through the next set, we had similar analyses, but now using the comparisons not at the trip level, the most disaggregate form, but at the route direction and period level. Here, the route direction and period would be more useful for practical analysis. The flows are more stable, etc. We use the same references as the base because we don't have a ground truth. We compare through the Hellinger distance. The idea now when we're doing these period levels, we don't need to match trip by trip. We just want to say, give me an estimate of what's going on in the period. So I no longer need to match across data sets. But we did want to have a certain size of our samples, basically in the B-Day survey, where we had a big enough sample where we could do a big enough survey sample where we could do our simulation samples, say what would happen if we had a 10%. So we could only do this if we had large enough B-Day survey sample sizes. Because we only got 34 trips when we screened the B-Day data for this period level analysis, we used all the data, screened and unscreened. Finally, as Rabia mentioned before, there were a lot of B-Day data that we did not use in the trip level where the data collectors would only survey certain parts of the trip. We developed a procedure to fill that in, pretty rigorous procedure, but again, in the interest of time, I'll skip the details. But what we're trying to indicate here is where the data collector only surveyed the first part of the trip, we might get trips like that. Here's where the survey collector only would get the latter part of the trip. Here's a trip where they get all of it. We use all three of the data sets to come up and basically fill in these trips where they only got the first portion or the end portion. With that, we had 34 trips at the trip level. At the period level, we're talking about getting bus trips on the order, thousands of bus trips. With the B2A survey, we got hundreds of bus trips, maybe on Route 7, for example, only 60 bus trips. But notice these partial trips are the ones we would get if we only, the partial trips are the ones where we only survey certain parts of the trips. And they're a substantial proportion of the overall bus trips. So this procedure we developed up here and implemented and documented is important to sort of get the samples, the data sizes up for the analysis. Again, we produced the different levels of comparisons for the two different references. We see there is variability among route to route samples, time of day period, etc. So let's look at the average results here again. So this is what we get, and when we look at across all route, direction, and period, get one matrix for a route direction period. For example, route 1 going southbound, or direction 0 during the morning period. Give me a matrix on that. Again, at the very top is what we get, what we call the null, the uninformative matrix. That's how different this null matrix is from our reference matrix. If we use, down here are the high-performing ones where we see we're using IPF data. This one right here, this curve right here, APC data, I'm sorry. This down here is where we use APC data through the IPF methods. We can use other methods in the future, but right now we're using the IPF method. This curve right here is what we would use if we got the B to A survey and only use that to estimate the matrix. And the importance here, again, is a function of the sample size. Even at the 25% sample size, which is higher than we think most people would do in practice, we're getting no improvement compared to using, for example, the IPF with AFC data or the IPF null matrix. That we're basically getting the same quality of data by using the APC data and not using any survey sample than using the survey sample. Similar on the other reference, it's even more characteristic here, more pronounced here, the effect. We did the same thing where we said how many times, because of the variability, does one estimate outperform the other estimate. We see down here they're not, for example, the IPF null or the IPF using the AFC as the seed is not outperforming these IPF methods when I use a 10% or 25% data nearly as much as it did at the trip level where we had high quality data, but still it's doing it a relatively interesting proportion of times. For example, up here it's 50%. And notice, again, it's hard to absorb all this in a quick presentation, but the data is, you can look at the data later. The increase in the average is small, indicating that when one method outperforms the other, it's probably not by very much. So, again,
This table just for a minute.
This table?
Yeah. So let me absorb for 20 seconds.
Okay, good. Need me explain the columns or?
Nope.
I will, while Greg's absorbing, also point out that the lower two rows have lower percentages than the higher two rows. We can, go through what it really means, but what it's really showing is using APC data is better than not using APC data. Again, you have to interpret.
Seems like all this is saying using IPF is better than using
Well, again, IPF is just a mechanism to use the APC data. There could be another method to use the APC data.
Right.
But basically, yeah, using the IPF is, so up here, using IPF is better than not using IPF. And if I use IPF null, oops, right here, or if I use IPF with an AFC base, it's not much worse than using IPF with even a 25% sample. The IPF, you can get the null base, you can get the AFC without collecting any surveys. That data's out there anyhow.
But all this says, the key thing is knowing boarding and lighting totals at each location. The actual connections between them tend to be lousy in any data you can observe, and you're better off just doing entropy maximization between the totals and good to go, right? I mean, you're getting most of the gain.
That's the point. Yeah. Give me those totals and use something like this. Now, an AFC base is a little bit better than a null base. But you're right. Just use something. Give me those totals and use something, and you're getting most of the way there. That
Total marginal, not total ridership.
total
Right,
mark.
total, right,
Yeah, the ons and offs, the boardings and all. You give me the boardings and all that. That's exactly
But
what
the
you're
connections between them is that you get out of your data is pretty lousy. You're getting, it's just.
Well, what do you mean by pretty live? What this is saying is, well, equally good as what you're getting from using
From
the
just
survey.
guessing, right?
No, from the survey, B2A survey. The
Yeah.
surveys are people going out and
Well,
they're actually getting the connection.
But
Now,
there
again,
was
the quality of the survey is a question.
all the gain is the IPF.
That's exactly.
The totals are, everything's up.
That's using APC data is valuable. That's the conclusion we're coming up with. Increasing the sample size, in other words, kind of what you're saying, we're coming up with a better base, doesn't really make that much difference compared to using the APC data. You're putting it, you're just rewarding what we're saying. Now, all of this, and basically using AFC as the base is slightly better than using the null, using nothing. So using something that's informative is better than this. Using a sample size like we get in practice really isn't much better than using the AFC. So most of the gain, you're right, is coming from using the AFC. Now that's all done, if I could. That's all done just saying, let me compare how well a B-to-A matrix compares to a B-to-A matrix for whatever purpose you want to use it. We then took this to the third comparison, which is now how much do these differences in the B-to-A matrix translate to the differences in the socioeconomic characteristic expansions. And there's where I'll turn it over to Rubin.
So now looking at the specific application of the expansion process, and I'll try to speed up. I know many of you are anxious to ask questions. Let's just recap here. This is the summary of the expansion process. Remember, there are inputs here coming from the onboard survey. This is specifically for the gender example we talked about extensively previously. And these are the B2A flows turned into proportions or probabilities. And that's what we are using to apply these sort of so-called adjustments or corrections of biases in the onboard survey, a characteristic determination. Just before we get into some of the actual sensitivity results, just quickly, this is an example of the actual proportions by income. So this is one of the many characteristics observed in the onboard survey. This gives the distribution of income according to the categories considered in the actual survey. We've aggregated those. These are results aggregated across all trips that are considered so-called local and on the COTA network, and the so-called all trips that are considered to be called cross-town routes on the network. Again, the idea is to give you an idea of the kind of results expanded income proportions here. We also did the quick spot checks where we compared these expansions to what AECOM separately expanded for COTA using the same data. The moral of the story here is that the numbers are more or less in the same ballpark. They're actually different, and the reason they're different is that the expansion methodology that we at OSU followed is an extension and a revision and a more rigorous implementation and configuration of what was done in the AECOM memo. Also, remember, these are aggregation across multiple trips, local or cross-town. We anticipate the results will be actually more perhaps different when we look at route-specific characteristics. But moving on, first we looked at how the errors, so-called errors in the inputs, translate to errors in the outputs. The inputs here are the B2A flow matrices that Mark talked about extensively in the last 20 plus minutes. So this, the Hallinger distance between the B2A matrix used for expansion from the reference, in this case we're looking at B2AS as the reference in this particular plot. We're comparing that to what we would actually see if we were to compare the actual expanded characteristic, where the expanded characteristic is expanded based on some B2A matrix that is used as an input, compared to the actual expanded results based on the reference B2AS in this case. So again, if B2AS were the truth, we would be looking at the errors in the input, how they translate to errors in the output. And we did the same thing using the IPF B2AS as the reference as well. Whichever reference, again, we use here, we notice an attenuation. A point on the 45-degree line right here on the unitary slope line right here would indicate that an input error would translate to exactly the same amount of distance or error in the output. However, you see the majority of the points, in fact 99.5% of the 99,000 points plotted on this plot here are actually, just trying to recover my cursor here, for some reason it disappears. All right, I guess the cursor is not working anymore. It'll come up. Oh, it should come back, okay. All right, so I'll try to describe what's going on. You'll notice, without the cursor, you'll notice some points that are sitting above the 45-degree line, and those are basically points associated with, they're, again, very small percentage of the points associated with the characteristics that are listed in the second bullet here: home zip code, the origin traffic analysis zone, the destination traffic analysis zone, and the boarding and traffic analysis zone. And that's not surprising to see the attenuation not being as strong, in fact, being slightly going in the opposite direction, where we basically, for the cases where we have characteristics that are highly associated with the B2A flows. So naturally, we don't see that attenuation for a certain small percentage, to 2.1 again to 5.6% that are above the 45-degree line for these characteristics. So still a very small percentage. So for the most part, there's a strong attenuation going on in this expansion process. Now we're interested in comparing how the actual expansions compared to different references. Again, the same two references are considered. In this slide, the B2AS is the reference. Again, because I can't use the cursor, I'll try to walk you through this a little bit more descriptively. At the very top in the column on the left-hand side, you see IPF all B2AS. So this is using all the B2AS data as a seed combined with the APC data through the IPF method. And what we see here is an actual mean Hallinger distance of 0.058. Again, this would be the Hallinger distance between an expansion of characteristics based on the IPF all B2AS with an expansion based on the reference. Again, in these tables, the reference is B2AS, as you see in the heading at the very top. So again, we are using different matrices for expansion purposes as listed in the first column on the left-hand side, going from top to bottom. and again, the corresponding mean Hedinger distances with respect to B to AS. The important thing to get out of this is that, again, there's quite a bit of variability, as you see from the percentiles, specifically as you see from the coefficient of variation, which is the ratio of the standard deviation to the mean. A very, very large variability here, so it's important to consider, again, that later on. But for now, just considering the mean values, which are in the second column here, you will see, again, the mean values, whether we're looking at IPF, B to AS as a reference in this particular table, or the previous table is the B to AS only. These are similar plots to the ones we showed previously, but now looking specifically at the mean Hedinger distance for the expanded characteristics based on different B to A flows as inputs. I'm going to go to the plot that shows the reference, considers the reference IPF B to AS, and point out, and it's a pity I can't actually use the cursor, but I'm going to try to point out a couple of observations here. First off, to explain what the null stands for in this example, this is different from the null that is considered in the B to A. This null represents what would the expanded value, what the characteristics would be without any expansion, purely as observed in the, thank you. Now we recovered, thanks to Kelly, the cursor. We see here that this is the line that describes the null. These are basically the Hedinger distance between the characteristics without any expansion compared to characteristics expanded using the IPF B to AS measure right here. All right, so that's basically the starting point, the worst case scenario. Let's think about it that way. Now we're going to look at what we get based on different expansions using different B to A flows. A couple of things to notice is that, again, this point right here, which is the IPF with the 0% B to AS, meaning we're using only the APC data. There's nothing else being used here through the IPF method and the null seed matrix. That would bring us all the way from here all the way down to here. This is a big drop in the Hedinger distance here, and on average basis. Similarly, if we look at what we get from the AFC data, which is this line over here, this is purely using the AFC B to A flows for expansion. Again, we see a big drop from purely using the AFC down to the IPF null, again, only APC data being considered. So that's an important thing to consider right off the bat. In addition, you'll see the IPF AFC. So this is now combining the APC data with the AFC data, where the AFC B to A flows are used as a seed. Again, you'll see this is sitting right here. Of course, it doesn't vary with the sample size of the B to A because it doesn't use these data. And again, we see this as a major improvement over IPF on its own, or again, the so-called null. All right, what's in the ODS in the onboard survey without any expansion. All right, so major improvements just by applying the IPF null and applying the IPF AFC. Now, introducing the effect of the B to A survey as a seed, as that percentage increases all the way to 100% in this case, we see a drop. So we see a further improvement, as you see in this bluish line right here. We see an improvement, but actually that improvement is really small in comparison to the major gains we get by going down from null all the way down to here, or from the AFC all the way down to over here. So that's another important consideration to keep in mind. And finally, or not finally, but one more observation here is when we look at the range of the sample sizes that are within the so-called typical sample sizes used in practice for B to A surveys, again, 10% or 25%, let's say 20% is the typical. Again, we see very little improvements when we're looking at the IPF 10% or 25% B to A survey. We see little improvement with respect to the IPF null, where only APC data are used.
I got a quick question.
Yes.
So in order to conduct this expansion, in terms of socioeconomic characteristics, you need to know something about the characteristics of the boarders and alighters versus the general population.
Right. You missed the part where we went through that. So maybe if you don't mind, let me come back to that once we're
well, I just wanted to get, because I'm starting to, a lot of this is leading me to think other than I could do without. If I had good counts like from APC, I don't need the boarding and lighting survey. There should be, well, how would I know? It seems like expansion is also helping the process to normalize into the characteristics of the full population, but I don't know those characteristics without the survey, right?
Well, remember, we need a reference. We needed a ground truth. If we had a perfect B2A flow ground truth, then we would have more confidence in our expansion. And that's because we didn't have ground truth, again, you missed the reason why, but basically the B2A data turned out to be fairly poor quality or questionable quality. We ended up using different references.
I think more to Greg's point.
Oh,
I think I see where Greg's getting at. This is saying, let's assume the expansion procedure is correct, that we're going to adjust it with this procedure. How sensitive is it to the input B to A? We can't say whether what we're getting, even with a perfect B to A, is representing the overall population. We don't have that data.
right. We don't have a ground truth, direct ground truth
Of the
characteristics. We're trying to generate,
population characteristics.
in this study, we're trying to generate what we consider the ground truth.
Right. So your baseline socioeconomic characteristics are from your reference.
Exactly.
Yes.
Exactly.
And the socioeconomic characteristics of your test cases do not quite match that, so you're doing an expansion to match.
The baseline characteristics are what you get when you expand with a reference.
That's
B to A.
That's what would be, if we had a ground truth B to A, that would be what we would consider quote unquote ground truth characteristics, but they're not directly
characteristics of your reference. Right?
Pardon me?
No, you were using the reference to expand the characteristics. And if you trust the reference, then you trust the expansion if you believe in your expansion methodology.
I would say we just need to move forward, and then at the end we can go into detail on things, and if people want to stay on the line and listen.
Because we have the line until 2 o'clock.
Correct.
Yeah,
This is pretty much if we didn't expand at all.
right. So that number right here is without any expansion at all. So again, there's major improvements.
Well, compared to the reference.
Sure, compared to the reference. And that's but again, the two references we use, again, similar results are arrived at. So let me just finish in the interest of wrapping up by 2 and allowing some time for other staff questions. Basically, we're saying here that the use of the B2A in the typical sample sizes, B2A survey data and the typical sample sizes provide limited improvement over what we would get only from APC data through the IPF null. Interestingly enough, when we consider the AFC, which is also automatically collected, of course, we get at the 20% at the 20% B2A survey level, more or less the same differences right here. One final observation to keep in mind: notice that this line right here, which represents only the B2A survey data without incorporating the effect of the APC data through the IPF. This line here is substantially higher in terms of the Hellinger distance, again indicating that it would be highly desirable, even if we were to have B2A survey data, to incorporate the APC data. And that we see in this case, and in considering this reference, at least up to about 40% of the sample size. Similar to the discussion Mark presented earlier, we also, because of the high variability in the actual HD values, we conducted a count percentage of times, again, the various methods without any B2A data, only using automatically collected data in comparison to the following expansions based on 10% B2AS, 25% B2AS, IPF 10%, IPF 25%. Again, these are the matrices used for expansion, matrices used for expansion. All right, so notice here that, first of all, the percentages here are lower when we're comparing the expansion results against the IPF 10% and IPF 25% compared to these. So in general, this is saying it is really valuable, again, to use APC when we're considering the actual expansion results as well. Another thing to point out here is that, notice, we have 50% of the IPF AFC the expansions based on the IPF-AFC outperforming the IPF 10% over here. This is more or less comparable to what we saw in the B2A comparisons at the period level. However, the results for the other percentages here in comparison to what we saw at the B2A input level, the actually percentages are in fact higher. So the conclusion here is that the attenuation we just discussed previously has a stronger effect on the results when we're using the IPF null and the IPF-AFC for expansion as opposed to using the IPF 10% and the IPF 25% B2A for expansion. So that's another important result to think to keep in mind. And then also, and finally, just looking at these numbers again, the percentages are sizable, even though they're not, except for this one, not at 50%. But then again, considering the small differences in the average values, that we expect that those cases where these two, the expansions based on these two matrices outperform the ones that do not rely on B2A survey data at all, in fact, are not very far off. And therefore, in this case, especially when considering the, again, IPF, especially IPF-AFC, we see no particular improvement in the quality of the expansion results. Again, to summarize the overall findings, B2A survey data collected at typical sample sizes offer little, if any, improvement in producing more accurate B2A flow matrices compared to estimates that rely only on readily available automatically collected data like APC and AFC. The second bullet here is about the attenuation. The errors and the inputs basically get attenuated when we translate them to errors in the expanded outputs. And finally, the B2A survey data collected at typical sample sizes offer no systematic improvement for expanding characteristics compared to B2A flow matrices estimated from readily available, again, automatically collected data. At this point, I guess we're trying to transition to the Q&A portion of the presentation.
You can type your questions on the link pod, and I will unmute phones in just a moment for those of you that would like to ask questions that way.
I've actually seen questions pop up along the way. Is there a record of them?
There is, but it was more discussion.
Okay.
Yeah.
Good.
On that note, if anyone has any questions that you think of afterwards, you can email Rebecca Anderson at the email address you probably saw on the TMIT post, and I will forward them to Drs. Michelani and McCord, and we'll get you an answer.
All right, we can hear everybody on the line. If you have a question that you haven't typed into the chat pod, you may ask verbally.
Here's one question. Were the APC and the AFC data used in the analysis from an average day or a month? We got 4 months of APC and AFC data. So it wasn't just a specific day or a month or an average. It was the average for the entire quarter during which we did the both the boarding to alighting survey as well as the onboard survey.
Almost half a year, actually. January through May and then September, I believe, for both APC and AFC. Again, at the bus trip level.
Any other questions?
Okay, thank you for attending. The recorded presentation will be available on the website within 2 weeks, and the actual final report for the project is undergoing edits and will be provided on the website along with the presentation, hopefully by the end of April. And if you have any questions in the meantime, feel free to email either Rebecca Anderson directly, or you can send it to research and the DOT research, and we'll go ahead and get that answered for you. Thank you.